Now, let's take a look at VLAN, virtual LANs, and how it helps the layer 2 networks. In this segment, we will look at, again, brief on the forwarding in switches and issues with switch hierarchy, and thus laying the background for introducing VLANs or virtual LANs. In the previous video, we saw how the switches forwards frames using switch table. Now, in this particular diagram, if you look at, these hosts have dedicated direct connections to switch. So C is connected to the switch through this link C dash, B dash is connected to the switch through this link, and each of these hosts are connected to the switch through 6 different ports, 6 different interfaces. Now, what the implication of this is that C and C dash can communicate with each other simultaneously as when B and B dash are communicating, or A and A dash are communicating. So any two hosts within the switch that are connected to the switch can communicate with each other simultaneously when the others are also communicating. So it does not lead to any collisions, in the sense that the switch does not get confused, or the end hosts also do not get confused as to who has received what packet from where, because the switch is able to manipulate around that. Now, each link, therefore, we say that has its own collision domain. The transmissions from A to A dash and B to B dash, etc., can happen simultaneously without collisions. The aspect of collisions got to do with the channel access in terms of contention. So if there is a single link that is shared by multiple entities, then the channel access part becomes a problem, because we can't have multiple people talking on the same link at the same time. So there is a CSMA CD and CSMA CA as channel access control mechanisms that are implemented by different layer 2 protocols. So in the case of switches, without going into details of CSMA CA or CSMA CD, in the case of switches, by virtue of the fact that this switch works in a particular way, each link is divided into different collision domains. If we take the case of hubs work at a physical layer, so every port in the hub is in the same collision domain, which means that if there are multiple hosts connected to the hub, then they all will be contending for or competing for channel access, because they all belong to the same collision domain. However, in the case of switches, each link belongs to separate collision domains. So a switch forward table, so this particular diagram here shows an example of a switching table or a forwarding table within a switch. It says that MAC address A is reachable through interface 1 with a TTL of 60. So this is how the MAC address table or the switch table gets built inside a switch. Similarly, when it learns packets or frames coming from different other hosts, it'll say B connected to interface 2 and so on. So the entire switch table gets built by the switch by itself. Now, we already saw the process for building the switch forward table based on destination and source MAC address lookup. So if a destination MAC address is not found in the switch table, then the frame is flooded out to all the interfaces except the interface on which it was received. And if it is found, then the switch forwards the incoming frame out of that particular interface. Now, we talked about collision domain. A collision domain formally is a set of network connected by a shared medium or through repeaters where frames can collide with one another being sent. In the case of switch, different links in a switch divide the whole network into different collision domains. However, if we have to broadcast a packet, then the switch does not divide the network into multiple broadcast domains. All the links, if you look at A, B, C through C dash, all of them would belong to the same broadcast domain, right? So broadcast domain is a logical division of a network in which all nodes can reach each other by broadcast at the data link layer. So in case we have to implement broadcast domain and different broadcast domains and different collision domains in a network, we have to use routers with switches or routers. Or if we have to use only layer 2 devices, then we have to have the support of VLANs or virtual LANs to help us with separate broadcast domains. Now, let's take a look at this particular example from Kuros and Ross network. You have an institutional network here where there are multiple departments, the electrical engineering department, computer science department, and computer engineering department connected through the set of switches and routers to an external internet. Now, so this is a switch that connects the devices of the electrical engineering department. This is a switch that connects the devices of the computer science engineering department, and so on. Now, in this case, if we have to communicate within the hosts in the electrical engineering department, then the switch will be sufficient. If we have to communicate within the devices in the computer science department, then the switch will be sufficient here, and so on. However, if we have to broadcast separately for each of these departments, then it is not possible to do it with this kind of a hierarchy because of the switch, and switches do not divide the network into multiple broadcast domains. So if we want to send out data to only all the devices inside the electrical engineering department, then it's not possible with this kind of a configuration. it'll go out to other departments also. The other issue with this kind of network is that there is an inefficient use of switches. So if we need to have more departments, for example, if you were to add a civil engineering department and a mechanical engineering department, then we need level 1 switches to be there, more level 1 switches to be implemented. This becomes a bottleneck in terms of network expansion. And it is also difficult to handle cases where an employee moves from one department to another. For example, if somebody from the electrical engineering department decides to be part of the electrical engineering department itself, but he wants to sit physically somewhere else, because this is eventually got to do with the cabling also. He decides to move physically to some other department temporarily, then that will result in the change of cables from this department to the other department where he wants to locate himself to. So these are some of the issues with switch hierarchy. There is lack of traffic isolation for broadcast traffic. There is inefficient use of switches, and managing users in terms of movement becomes difficult. So the solution here is to provide a switch that supports what are called virtual local area networks, or VLANs. Many of us would have heard the term VLANs, but let's take a look at what VLANs are at a high level. Now, VLANs are multiple virtual or logical LANs overlaid on the physically connected LAN. So you have the physically connected LAN itself, but then you add a logical layer or a virtual layer on top of it in such a way that the functionality of virtual LAN gets established. A VLAN is useful if you want to treat different streams of Ethernet traffic differently without having to run separate cables. So it saves us on the cost and the work of cabling also. So this is what we do in that particular switch. This particular switch here, if we want to change the configuration, then what we do here is we configure ports 1 to 8 as belonging to the electrical engineering, ports 2 to 8 as belonging to the electrical engineering department, and ports 9 to 15 as belonging to the computer science department, right? So that is a single switch that is configured with 2 different VLANs. Now, what does the switch do? How does the switch know whether it is a VLAN that has been configured for VLANs or not? So we need to make that configuration of the switch. We have to configure a port to be belonging to a VLAN. It's a configuration that we have to do through a CLI or some other manner. The switch maintains a port to VLAN mapping. So it says port 2 belongs to VLAN electrical engineering. Port 9 belongs to VLAN computer science engineering. Port 10 belongs to VLAN computer science engineering. And then when the frames actually get delivered, the switch's hardware would deliver the frames between the ports belonging to the same VLAN only. So if there is a broadcast traffic coming in from somewhere else, then, and it is meant only for computer science VLANs, it look at the traffic, and if it is only meant for the computer science VLAN, then the traffic will be forwarded out only to the host connected between ports 9 and 15. It will not forward the frame to any of the other ports in the switch. So this is the logical part that results in separate broadcast domains inside the same switch. Now, with this configuration, also called port-based VLANs, we have multiple advantages. One is, this is a configuration, so there's no hardware, there's no cabling or any other infrastructural changes required. Configuration done on the switch. Now, if somebody wants to move from one department to another, not logically, but just physically, then only the configuration needs to change. So suppose this particular host wants to move elsewhere, we can have the same host that is connected to a different switch, but can be configured with the same VLAN number. And that will eventually lead to kind of network hierarchy where you have multiple hosts in different locations, but they're all connected together by the same VLAN ID, which means that they all virtually belong to the same LAN. So it kind of provides traffic isolation between these ports. It also supports the movement of people from one department to another. And this is a kind of functionality we're able to achieve. You have one single switch, but then it kind of looks as if we are operating multiple virtual switches, which are separate from each other. One switch dedicated for the electrical engineering department and another switch dedicated for the computer science engineering department. So what we saw in this segment was we looked at the forwarding functionality in switches. We applied it to an institutional network, and we realized there were some issues with the switch hierarchy in terms of allowing for more departments to be added, in terms of allowing people to move physically from one department to another, and also in terms of providing traffic isolation to broadcast traffic. And therefore, we established VLANs as a solution to overcome this. And in the subsequent videos, we'll look at a little more detail on the VLAN characteristics and how it is enabled.